So Vidya, welcome. How's everything going? Where you basically joining us from? You wanna a little bit introduce yourself, and
Sure.
we are excited to have you here.
Thank you. I'm joining from Seattle, Washington. I live in Redmond, and everything is going very well with this pandemic thing. I hope everybody is keeping safe. So, thank you so much for organizing this. I think this is very much needed for the community and utilize this time to learn. And I'm really excited to talk about microservices architecture.
Awesome. Thank you for being here, and just go from it. And I'll be joining you after the session, and we'll have panels after that.
All right, sounds good to
All right.
me.
Okay. Thank you, Vidya.
Thank you. So the topic today I'm going to talk about is microservices architecture, also known as MSA. Uh, this is sort of a new buzzword in the crowded streets of software architecture, and it is becoming really prominent to learn about microservices architecture. Um, Before I really dive deep into the session, I want to give you a little bit background about myself. So um, I have like 18 plus years of software industry experience. I'm working as a principal architect with T-Mobile. I'm also a CSharpCorner MVP since 2013 and Microsoft MVP since 2014. I'm also TOGAF certified architect, certified Scrum Master, have almost a dozen Microsoft certifications, published author of these 5 books, and a technical reviewer of these over a dozen books as well. So the agenda I have, the key takeaways from the session I want everyone to have is what microservice is all about, how it differentiates from its predecessor, Monolith, what sort of patterns companies are implementing, what sort of mindset and culture is needed, what are the pros and cons, and I will share some of our journeys at T-Mobile as well. And I will take some questions as well as I will see and we go through. So before we really get into the weeds of microservices, it is very critical and important to understand what is monolith or even a SOA architecture organizations has been building REST APIs with. So since REST APIs or APIs are built using MVC pattern, you can think of any MVC application um, which is having all your API code base, and then you have your POJOs, that is plain old Java objects, or POCO, plain old C# objects, and you are writing all those controllers, models, views, your repository pattern, and everything within one solution or project. When you do just a layered architecture that you divide your cross-cutting concerns in different layers. But entire project, entire bundle is being built together and then it's deployed together. And you will, most of the time, you will end up having one large monolithic database. And mostly it will be a relational data store. Call it SQL, Oracle, MySQL, whatever you have. If any application is written with these settings, and then this is primarily a monolith application. Now, there are some benefits because what I learned is that architecture, there is no good or bad architecture. Architecture is all about choosing your trade-offs. Maybe based upon the trade-offs you are okay to receive with and live with, your architecture may make sense for most of the time. But are there better ways to do it? Yes, of course, but then there are more growing pains with that. So let's learn about what are the pros and cons of monolith first. So the first benefit which I see with a monolith is that you have fewer less cutting concerns because everything is built together as a one single bundle or deployable unit. You have less cross-cutting concerns. Having said that, if you build your a logging layer once, that will serve all your APIs in all your API controller, let's say customer order, payment, address, notifications, everything will work just fine. Now, next one is you have less operational overhead. The reason is because you are controlling everything as a single unit, you have less to control, you have less to really operationalize. And once you have operationalized it, just one thing to look at and really be with it and keep it up and running. So it is less complex to deploy and less overhead to manage it and operationalize it after deployment. Performance, because all the services will be living in the shared memory space, you are not making any calls or REST API calls over the network, like which happens if your services are deployed in different containers or distant apart in different regions and whatnot, then you are not getting into the trap of network latency. Hence, performance is always better in monolith than in comparison to microservices. When we talk about benefits, we always have to consider and talk about disadvantages or cons as well. The biggest disadvantage of monolith is it's deploy all or none. Having said that, when a new change needs to be published or pushed to production or production-like environment, or call it non-production environment, for example, staging, uh, whole service stack needs to be deployed. I have been in those situations when I'm making a very small change, but I have to redeploy entire REST APIs altogether to the cloud because that's how it was built, because it was following monolith architecture or SOA. Now, scale all or none. Scalability has been the biggest concern in industry always, and the more customers we have, the more we grow. Scalability is like having growing pains. So what happens with that thing is, since all your controllers, all your APIs are built once as a single unit, so you have customer, order, payment, inventory. Think about these four for now. What you are doing, you are deploying all these four together. But when we at T-Mobile, we launched pre-order for Apple iPhones in 2019 in September, October timeframe, whenever that time comes, let's say, or any new marketing promotion happening when you are allowing customers to pre-order something and people are going crazy about it, like Apple products, for instance. Now, does it mean that we scale entire T-Mobile stack of 23 domains because we have to support that pre-order event in the night? No, because we are into microservices space and microservices architecture across domains. What we did, we only scaled those services which were prominent for that. For example, payment. For example, catalog, that you can go to catalog, search the product you want, what color you want, what configuration you want, pick that, place the order, make the payment, and you are done. So payment, our catalog services, and order management. And not inventory even, because it's a pre-order. So we are not shipping anything to you until it becomes available, right? So you have choice to really scale only those services which people want at that given time. If you are in monolith, then you have to scale entire stack up no matter what. And you have, even in that case, scaled up customer service, order management service, address verification service, your notification services. Everything is scaled up, and that is more cost, more burden, more operational overhead. Now, the other disadvantage which people have been noticing with monolith is about single point of failure. Sometimes it is also known as SPOF. Just take the first initial of each word. And that's the biggest problem in software architecture. Navy SEALs say that two is one and one is none in high availability concepts. I will repeat it one more time for you guys. Two is one and one is none. Having said that, always have at least two. So do not have a single point of failure. If a server is down, entire functionality is broken. Having said that, if there is something wrong even with one service, because all those are sharing the same memory space, what will happen is entire web services can go rogue, and we call it noisy neighbor situation as well, because one service has started taking a more thread and resource consumption where you have deployed your web services or APIs, in this case on cloud or wherever, and then it will slowly bring all the resources down, and even other services won't be able to respond. Now, so I think we learned enough about a monolith. I wanted to give you some background about monolith, its pros and cons. Now let's really dive deep from this point onwards into microservices only. Now, what happens is with microservices is that, first of all, what is a microservice? You can take a lot of keywords here, and those keywords are that microservice is a tightly scoped, loosely coupled, strongly encapsulated, independently deployable, independently scalable, even independently testable application component. So these things are microservices where you take one thing and then you just live with it. You just work with that. Now, what happens here is that the global microservice market is anticipated to be accreting to $33 billion by 2023. So that's the thing. All these things you see today, like AI, IoT, anything you talk about in today's world, because everything is at the end happening through REST APIs over the network. Everything is using some sort of REST APIs or APIs, and all the organizations are today adopting to the culture of microservices architecture. Now, when we work with microservices, it is very important that how do we find a single deployable unit? How do we find that which API will live in which microservice by itself? And that's the trick, and that is where the old concepts since 2003 come into the picture of domain-driven design. Now, domain-driven design has a keyword in it called bounded context. What bounded context says, bounded context is can be described as an explicit boundary within which a domain model exists. As you can see here on the left-hand side, I am showing a monolith architecture, and that is where your application look like. Think of any MVC application or any web application could have been built using Angular or whatever is the framework of your choice for a front-end technologies. Now you have here a UI, and that UI is now talking to multiple controllers which are being built together as a one single project of multiple controllers. So you have a customer controller, payment controller, inventory, order, shipping, billing. All these different controllers are living as one single unit in your project. And then they all are talking to one monolithic large database, which is a relational database, of course, where all that primary key, foreign key thing, joins and all that you do. You have, of course, I'm not showing few layers here, but those are understood that there will be a repository pattern and your business logic layer and data access layer and your logging and security and all that good stuff you will have, of course, in your layered architecture. Now, if I really want to give you maybe 10, 15,000 foot view at a high level, how this thing can be transitioned into microservices architecture is look at the right-hand side now. So you have your application UI, your front-end thing, and then that front-end now has been talking to multiple small, independently deployable, independently scalable microservices. Having said that, if you want to really visualize and you are hands-on developer, think of taking your customer controller out from that one project and making itself a new project. Means it will produce its own deployable unit, it will build and publish by itself somewhere to an endpoint, and you will hit that endpoint to talk to it. And not only this, you will also have its own dedicated database. It could be relational, it could be non-relational. We can talk about it later, but the keyword here is it will have its own separate database. Means you have even broken down this big, large monolithic database into multiple small databases. That is what microservice architecture is. So I hope this makes sense. Over the period of time in this presentation, I will talk more about it, and keep posting your session, your questions in the session here. We will see what we can do about those. Now, I want to really give you some real world examples that how microservices are connected and utilized in the world today. Now, this is something which I'm showing here how microservices in action will look like. Now, if you see this entire screen on the left-hand side, I'm showing a composite UI. This is, I think, a very old user interface, the real web page of Amazon.com. Now, why I picked that example is because Amazon is really good at doing it. Netflix is doing it. We at T-Mobile are doing it. Many large organizations call it Uber, Facebook. Everybody is doing it. But the key point here is that how it works actually. Now, if you see this entire screen on the left-hand side, which you are seeing here, and I have done some red framing for you guys, is that these are 7 sections. So 1, 2, 3, 4, 5, 6, and 7 at the bottom. This is seventh one. Now there are 7 sections in this UI. Now consider that all these 7 sections are showing some specific functionality or capability on Amazon.com. And all these functional areas supposed to retrieve data from some backend, of course, right? You depend on some backend systems to pull that data out. If you are really building a small application, your backend is just your data store. But large companies, they depend on payment domains. Now, at T-Mobile, we have our own payment domain, which is in-house payment domain. We call it DPS, Digital Payment Services. Similarly, we have Digital Billing Services. We have DFS, Digital Finance Services. And then those domains talk to further, backend systems. So our digital payment services talk to further, some payment acquirers. For example, WordPay. For example, maybe some bank which process the payment which we receive from the customers. So when we take your credit card information, we pass it down to our digital payment services team, and then they pass it down further to the payment processor, for example, WordPay or a bank, for instance. So these 7 sections are actually connected to these 14 services over here. Now, these are the backend services, total 8, and then these 6 are the UI composition microservices. Means this section, if I see the second section from the top, you see that component composed view model. This has one microservice, and that microservice has the capability to talk to one or more backend services. Means we call it scatter and gather pattern. In microservices world, it is also known as aggregation pattern. Means one microservice will be invoked by the UI, and that microservice will go to the backend, make multiple calls to different backend systems, bring data back, massage it, scrub it, and give a JSON response back to the UI, and that's how UI will work. Now, this is how microservices are composed. At T-Mobile, we do the same way. Amazon does the same way. So this is a pretty proven pattern in software industry, and all the organizations which are really high-performing software organizations and have leveraged microservices architecture. Now, I hope you understood what was Monolith, how it looks like. I gave you the 2 screens of the image of Monolith and then the microservice. I will keep showing you microservice architecture here so it stays longer with you. Let's talk about some of the advantages of microservices. So it brings a lot of advantages, a lot. So first example, the most loved one in industry is the scalability. You do not have to scale everything. Many times people think I have cloud, I can scale whatever I want. Yes, of course you can, but do not forget that cloud is always pay as you go. The more things you scale, which you don't need maybe, your cost will keep recurring. You will pay more money to the cloud providers, right? So scalability is the biggest thing because you have flexibility in your own hands to only scale what you want to scale and nothing else. As I gave you one example of the Apple iPhone launch in 2019 and how we scaled only some services and not everything. So if you see here, you can scale only the service which is in need at that given time up to whatever level you want. Now, second thing is easier deployments. Why easier deployments? Because every service is independent of itself. So if you want to make some changes in customer and you have ensured, because everything is exposed by some API contract, as long as you are not breaking the contract with your consumers or the clients, you are fine to make any changes and deploy it or launch version 2. There are all that good practices and principles and best patterns available to follow along. So if you make changes in customer, you only deploy customer and everything else remain untouched. You don't deploy that. Now think about the time it takes. Think about the effort it will take for test and certify that you can deploy that change. The only practices you need to bring in is a very heavy investment into unit testing, a very heavy investment into good DevOps practices, because it takes a few things when you go with microservices architecture. Now, the next one is problem isolation. I think I already explained it. If something goes wrong with customer service, the rest of the service will stay untouched. There will be nothing happening to those because of problem isolation. That problem isolation is actually achieved inherently by microservices architecture, because microservices architecture by itself, um, you know, innately or internally or naturally follows single responsibility principle. Just FYI, single responsibility principle is the number one principle in solid design principles. Also, when people work on microservices architecture, it really develops or generates a deep domain knowledge. As I gave you some examples at T-Mobile, we have different microservices teams and different domain teams, of course, then only you can do microservices architecture. What happens in our space is we have teams like a digital payment services. So that team now owns a payment domain. So they have built a lot of deep knowledge about how PCI payment card industry works in this case. Now, the other one I want to talk about is polyglot programming. A polyglot means that you can take advantage of multiple programming languages. Since every microservice is different by itself, think of that whatever microservice you do, you can develop those microservices in different programming languages altogether. Means there is no foundation or restriction on you that you have to use only .NET Core and Service Fabric, for instance. If you are comfortable, you can write inventory service using Java Spring Boot, and then you can use a MySQL, whereas customer service is written using .NET Core, Service Fabric, and a SQL Server. The third one can be written using Python and Oracle, whatever you want. However, there are some problems with that approach because you have to maintain multiple programming languages. Not only that, you also have to maintain different knowledge bases. And if somebody leaves that team and microservices built using Python or Java, Spring Boot, or .NET Core, and you are not familiar with that thing, then you have acquired a learning curve. And then you have to work with those things. Now, I think we talked enough about advantages, and I hope and trust that that gives you a very good insight about why companies are really going behind microservices. And as I said earlier, architecture is all about choosing your trade-offs. You are always aware what risks you are falling into, what sort of pains you are going to accept that, yes, I will live with it. And that's why, a great freedom comes with great responsibilities. So if it is giving you freedom, there are a lot of responsibilities and of course, pains. So the biggest disadvantage or a pain point I can say is a cultural change. I have not seen any team or any organization just waking up one fine day out of the bed and say, okay, today we are going to do microservices architecture. There is no such thing in this world. And if anybody does it, you will fail, miserably. So do not do it. It's a cultural change. Your leadership, your CTO, CIO, your VPs, your directors, all of them has to be aligned and agreed that yes, we are going to do microservices architecture because these benefits are more valuable to us than the disadvantages we have in hand. And we are okay to live with it because we are customer facing organization. We are building a line of business application and customer comes first. Business agility is key for us. And we want to live with microservices architecture. And it's a heavy investment, let me tell you that. So it's a cultural change, first of all. You have to change your mindset to adapt that culture and then get into microservices. As you will be breaking your multiple services which were living and built together maybe by one cohesive team into multiple services, small microservices, it is expensive in a way. You have to spin multiple projects, you have to spin multiple pipelines, you have to have multiple DevOps people, multiple Scrum Masters for each team, and things like that. So you can multiply all those factors, and then you will realize, oh, yes, it is more expensive in a way. Um, since I talked about expensive and cultural change, it is complex as well. Why it is complex, I will tell you in a very easy manner. I will let you live with this phrase that microservices has more moving parts. The more moving parts you have, the more complex it is because there are multiple services, as you can see on the image I'm showing on the right hand side of the screen. You have multiple services, multiple database systems, and as you might have realized by now, if you have any background in database systems, is there's no primary key and foreign key relationship here because they all are far distant apart databases. Not only that, they are different data stores as well. There is no guarantee that customer information is stored in a relational data store. chances are it could be NoSQL because you read a lot of information about customer. When you log into any website, you log in, what do you see? You see your customer information, your profile comes back. And that is most of the time it's NoSQL because that thing is read heavy. So whenever we are read heavy, we use NoSQL for that. Now, since we talked about all these three bullet points on the top here, the fourth one, of course, is less productivity. It is less productive in a way because you cannot quickly deploy things faster. You cannot quickly make changes and test everything together. So that's why it is a little bit less productive. But I have seen teams, even we at T-Mobile are at that stage when our productivity is going high because we adopted that culture very well. We have placed best practices and principles and culture and approaches and that mindset in place that which is making us to achieve now productivity the level we want to be, and we can proudly call ourselves a high performing software organization. So there are some best practices you need to live with and really adapt to really be productive. But at initial stages, for few months, for few years even, you may end up with less productivity. So the other one is communication between services. Remember the fallacies of network computing. There will always be latency. There will always be hiccups between your REST API calls you are making to other container services, Kubernetes, web APIs you have deployed on cloud anywhere, or the REST endpoints, just call it that way. Now, those things will keep happening. So communication between services will be a problem. You have to really think far. How do I design services that if one service is down, what do I do? And I will give you a couple of examples how we are solving those problems at T-Mobile. Harder to do integration tests. I do hope you know the test triangle. The number one, if you put the triangle like this at the top, of course, at the top are always the UI tests, your functional automation tests. It is not advisable to have so many UI automation tests because if you change something in UI, your test will start failing miserably. Now, number two comes down to integration tests. And that is where the pyramid becomes a little bit wider. And then at the bottom, which is the most wider part of pyramid, is your unit tests. So that is where you put the unit test means if you do microservices, you have to really do amazing job in writing unit tests. And of course, you can do integration tests, but it is a little bit harder to accomplish because of making calls to the other services and whatnot. But it's only hard, it's not impossible. So just be aware of that. Now, with microservices architecture, as I said earlier, since there are so many moving parts, you have to really begin with your architecture with the right approach. Sometimes this statement may come like a little bit in a challenging approach that can somebody create architecture which is well defined from the beginning? Answer is no. You cannot do that all the time. So what we do is we think about all the right pieces, right approaches, put proper thinking in place, just be a little bit more diligent how you're designing things and make those decisions what to pick. For example, in architecture, there are few decisions which you can change and there are few decisions which you cannot. I will give you one example. Can I change my caching architecture? Yes, you can. I'm living with now Redis cache. Tomorrow I can go with Gemfire, right? That is easy. But how about changing a programming language altogether? I started with Java Spring Boot. I wrote entire microservices having few 100,000 lines of code. And now you want to change that programming language from Java to C Sharp. This is very hard. You should not be doing that. If you do it, you will end up having a lot of money wasted because you did something in previous language and now you want to rewrite it. So there are things like that which you can change, which you cannot. So be aware of these things. And then the next one is I want to give you some insight into. I hope you have become more interested now to think about how people are doing it because, as I said, nobody can wake up and just begin with microservices architecture unless you are a brand new company who is going completely greenfield. You are starting something brand new, then you can begin with it. But most of the companies do not. They slowly migrate their SOA or monolith applications to microservices architecture. So first step is that do not switch from monolith to microservice all at once. Do not do it. There is no way you can transition overnight into microservices from your long-lived monolith or SOA application. So Remember, I told you that you have your MVC application where you have different controllers, customer, order, payment, uh, notifications, all these controllers you have. Now just take only one controller out. Take that entire code, models, its logger, its repository, business logic layer, whatever you have, take it out into a separate project and then start building it. Having said that, we are trying to accomplish divide and conquer. So you have to inspect your monolithic system to see what it hurts the most. Which one is the one which is having more pain point? Which one you deploy often? And then you are deploying the entire website or entire web application or entire REST API stack you are deploying. So take that thing out, start building it separately, and then slowly transform that part into a microservices so you can deploy only that without impacting or touching your rest of the API controllers, which are still living in the monolith world. And once you are successful here, you take the other piece out and then the other piece out. So take the steps like a crawl, walk, and run. Do not try to accomplish big bang that you want to accomplish everything all together unless you are greenfield. Now, there are few patterns and principles and best practices I also want to uh, share with you that whenever any organization is doing um, microservices, owning microservices becomes very critical. That which microservice will be owned by who, which team will own what. And since you have so many moving parts in microservices architecture, what happens is, unlike monolith, of course, what happens here is that you will end up having multiple teams, and that's why it becomes more complex and less productive, and cultural change. That each team will own one or two or three microservices in this case. Now, so if you have a payment team which owns only payment microservices, and if you guys are thinking that what is so much in payment that we have to have a separate team, and how big of a team that would be. So I will give you one more term here that is called two pizza team. A two pizza team is a term which Amazon, I think Amazon provided that term long ago when they started. And two pizza team means the size of a team should be able to be fed by two large pizzas. So think about it. If you have two large pizza, how many people can be satisfied with that? I would say 7 to 9 people plus minus two. So that is exactly the size of an API team or a front end team. If you remember that image I have shown earlier of Amazon.com, where you had 7 sections in the UI and 14 microservices. So in many companies like Amazon, even we at T-Mobile do the same. Even your UI is divided into functional capabilities. So somebody owns only payment part, somebody owns only account management, somebody will own order management, and they build only those components in the UI. And then they talk to those microservices team, which provide you the capability to serve the functional behavior to the UI. So your API is the technical side of it, your UI is the functional side of the house. So coming back to the point here, if you see, team one is owning payment and order, and team two is also owning order and billing. Means order service is now owned by two teams, which is completely unfair and nonsense. If you also see here, a shipping service, nobody owns it. There is no team which says I own shipping service. So when you divide your teams into microservices land, be aware who owns what, and there has to be clear definition of owning it, and then the ideal will look like that. So any services can be owned by any number of teams depending on the budget and the size of the team and how you are evolving in the microservices culture. It will take time. It's not easy to spin multiple teams. At T-Mobile, we have a few dozen teams who work together to make applications work. Um, and then what happens here is you can also debate how would I choose which team owns what. So the more experienced developers and leads and DevOps resources can own more complex microservices, maybe one or two together, but they should not own more than two, I would say, because then it becomes more complex for them. And smaller services can be combined together. Some services which are not changing often, for example, cart service. What do you do in a cart? You add item to the cart, you delete item from the cart, you can increase quantity in the cart, you can save later. These are very limited functionality a cart have on any e-commerce website, right? So cart service is a very small, lightweight service, maybe not many changes happening. So any team can own it. You can slide it to any team and that team can start owning it, right? But at the same time, each team has to have their own CI/CD pipeline, DevOps practices, dashboards, monitors to really monitor and have the pulse that each service is up and running at all the given times. Now, as you can see on the right-hand side of the screen, the service ownership is called as STOSA, a single team owned service architecture. If you want to learn more, you can go to CSharpCorner. You can read my article about it and then learn more about STOSA or single team owned service architecture, where I have described it a little bit in more detail about it. Now, when we really divide microservices, and as I said earlier, there are so many moving parts, it becomes very critical uh, that you really decide how microservices will behave together. So this screen is a Netflix's screen, if you have not recognized so far. So what happened in Netflix is they show you different banners, right? So they show you watch it again. They show you everyone is watching. They show you continue watching, right? They show you all these things. Now, think about how this data is coming, how Netflix lays out this data, or how even we at T-Mobile show you all that data which renders on your screen. If you go to let's say you ordered an iPhone or any phone you ordered, you go to order details page. We show you so much information there, even what credit card did you use, what is your billing address, what is your number, what phone number do you have, what is your address, where are we shipping it to, what device did you order, can you track it to UPS or whatever, right? How do we show all that information? There is no one microservice we are making call to. I have designed architecture where we are making call even to handful of microservices. So you have to really be aware of how we are pulling data from, where that data is coming from, and what are the consequences if one data is not available. So the example I'm giving you here is, what if a microservice which is showing you everyone is watching goes down? What will happen to your Netflix screen? Does it mean you will say that entire Netflix is down? If it was Monolith, maybe, because what you do in that case is you expect 200 um, response from the REST API for everything altogether collectively. But in microservice world, this is not possible. You cannot rely on 200 coming from every single service and then only you will present the screen or data to the customer. We are living in a world where customer is the king. Every company is going customer first mindset, customer obsessed. You have to do something on your own so customer doesn't feel the pain. And as I said earlier, you cannot have a single point of failure. Remember, two is one and one is none. So all microservices are deployed in some sort of high performing, highly available, highly scalable containers in Kubernetes or Azure Service Fabric and wherever in the cloud or on-prem, depending upon your hybrid architecture, of course. What happens here is if Netflix feels a glitch or a hiccup to pull data from everyone's watching microservice, they will start showing you trending now, even though they still show you that. Or what's new, or you may be interested in watching this thing. And by the time you with your remote, you will go up and down in the screen. Where is everyone is watching, or where is continue watching, and your profile name, as I'm showing at the bottom. It takes only few milliseconds, few hundred milliseconds to have recovery of that microservice which was down, because by then your load balancer will start transferring data to the next container deployed in your container yard, maybe Kubernetes or whatever you are using, or Azure, and then it will start receiving response back, and you will see, oh, here is the banner I want to continue with, right? So that's how things happen. Now, let me give you a few more examples about it. Slowly we are building. So there is something in industry today is called 2-second rule. We at T-Mobile also follows that. What 2-second rule mean is that every single thing should happen in 2 seconds. Means your website should load in 2 seconds, order should have been placed in 2 seconds, payment should have been processed in 2 seconds. And if I want to do whatever, I just do it in 2 seconds. Is it really possible? So first of all, what is 2-second rule? Let's understand that. So 2-second rule is a very loose coupled or a loose principle that a user should not need to wait more than 2 seconds for certain types of system responses. such as application switching and application launch time is the common one. And that's why many people who expertise in a user experience analysis for websites, they want to see how quickly your website launches, which section is on which side of the website. Like they see, a usability of usability of your website. If your website or blog or whatever takes long to launch, you lose interest. We are living in the world where every human being is having less and less attention span. Our, the time span for attention is going short and short. We have no patience left, and that is fine because there is so much information flooded around, and that's another problem. We have so much to digest and assimilate, and really pick and choose which one is right and what I do with that, right? So 2 second rule is really prevailing and taking part in it. But having said that, how do these high performing software organizations do it then? So let me give you one example. Let's say I am placing an order, and this is a real email from my own personal email ID to Amazon. So what if you have ordered anything online on a really nice website, for example, Amazon or whatever you use for your own purposes? If you see, what you do is the moment you add an item to the cart and you say place order or buy now or whatever it says, you will see just like a flick, you will see order confirmation page, right? Now, let's break it apart. What is happening in the background? What is happening in the background is, do you think that your order can be placed just like that, just on a click of the button, and they took your order and they will process it and they will ship you the item? No. What they do is, what are the steps involved in this domain? Now understand that. Once you have placed your payment information and you place the order, what has to happen in that case is they need to verify whether item is available in the inventory or not. That is step one. If item is available, let me take the credit card information and verify that credit card information entered is correct, and then secure the payment authorization, right? So all the e-com companies like we T-Mobile are also e-com. We are in retail also. We have B2B, we have B2C. So we are pretty wide software company in telecom space. Now, what happens next is no e-com company can charge your credit card until they ship you the item. They do not charge you. So what they do, they only hold the payment authorization of that much amount onto your credit card. Means if you have $100 limit and you are buying a $50 item, they will hold $50 on your credit card limit until they ship you the item. And once they ship it, that amount will start reflecting in your statement on the credit card. That's how companies do. So they have to get the check, do the inventory check, secure payment authorization for the amount which you are buying an item for, then send that information to the shipping company, shipping domain. Can you ship it to this zip code which this person is asking this item, right? And then place the order, and then wait for 200 response code from all these services, and then only show you the order confirmation page. Now, you might think I can accomplish it by firing asynchronous API calls to multiple things, and yes, that's how it happens. But many times, what if your inventory service is down? Think about it. What will you do? Will you keep retrying? Yes, there are retry patterns in resiliency. Resiliency means an application which can fail fast, which can self-heal. It's all resilient architecture, right? Now, does it mean they will wait for inventory service to keep retrying after every 200, 300 milliseconds, or maybe after 1 second? Then you are on the screen for 2, 3, 4 seconds already, but you receive nothing. And what you do, you get fed up and you go away from that. Or maybe your system will hang or whatever can happen, right? You lose interest in that. But this is not how high performing software organizations do. What they do is they show you immediately order success. And what did they do? They put that thing, once it started failing, they put that in a queue. That queue will keep retrying. And once they receive the response, they will process your order. So this email, it has happened with me a couple of times, not just one time. And I do know how it happens and how it works in the background. So what happened here is that they processed the order just to show me order confirmation. When they went in the background to inventory, maybe by the time they had a last known good number of the item which were living in the inventory when they were taking order from me, maybe that item was gone. I'm sure Amazon has the capability to try to ship that from different warehouse, if not in Washington or nearby. They can send it from Los Angeles, from Oregon, from anywhere, right? Nearby, of course. But if it is not available in any warehouse, then they will politely send me an email like this: order cancellation, that we could not fulfill your order is canceled. And anyways, they didn't charge me, so I don't need to bother about it. But why did they do it? They did it because this thing is okay, because they tried in the background to fulfill my order, but they could not. But they win my trust at the beginning that, oh, this website is too fast. And they always keep multiple items and inventory check handy at runtime when you are placing the orders. So they do all these good stuff just to be sure that they are really following 2 second rule. At T-Mobile, we do the same thing as well. And we do certain things to really make sure that what happens. So I want to also talk about a couple of patterns here, which we at T-Mobile also following along. The first pattern is a bulkhead pattern. As you can see, bulkhead is a term actually which comes from the shipping industry, like boats, ships, cruises, all these things. And it means is it's tolerant of failure. That's what bulkhead does in ships. So as you can see on the image I'm showing on the right hand side, which is a boat, you see those two vertical partitions which divide the boat into 3 sections. What happens here is if there is a water leak or a damage in one section, the water will not, flood into the entire boat. Rather, it will lock itself into that small section. Uh, every ship which is sailing today in the ocean or even being built is being built with this mechanism. So this bulkhead approach really works well for ships to lock the water body within one a closed room with really, uh, airtight shutters and doors, and so water locks in there and does not flood into the entire ship and have it sink into the ocean. So having said that, how do we bring that pattern to the software field? Let me give you a few examples here. So there are few problems which we have in industry, in softwares especially, is propagation of failure. So let's say if one microservice or one service go rogue and it starts failing, then what happens is it has started consuming resources more and more than it required to. And then what happens is the other services started failing as well. This is also known as noisy neighbor situation, because one service is taking so much resources that it's so noisy in a way that other services cannot live in peace or cannot do their own thing. And it also comes to unusual demand. So I will give you one example of how we solved that problem at T-Mobile. So think about the left one. In left image, I'm showing microservices A with connection pool for X and Y. So there is only one connection pool. I'm talking about bottom left section, where there is one large connection pool talking to two microservices X and Y. Now, let's see what example I'm going to give you, which is a live example. So at T-Mobile, I'm working now with a B2B team, which is business to business. So we serve large enterprise customers, military, government, education, small enterprise customers as well. Now, at T-Mobile, the consumer line, like I'm also a T-Mobile customer, you can have up to 20 lines. If you are a normal consumer, like a household, you have family members, I can add up to 20 lines in there. Whereas for B2B customers, you can have up to like few thousand lines, right? So let's say I'm a brand new customer and I want to utilize T-Mobile services, and I want them to spin me 1,000 lines and give me all Samsung phones or Android phones or Apple or whatever, right? So I say, okay, give me 1,000 numbers, which I will give to my employees. Now, we at T-Mobile for Business or B2B team I belong to, we do not process that. It goes to the billing team. Billing team will provision the number and create the billing account for them, and then provision those numbers and work with the different backend system. Then digital payment services team will take the payment processing and whatnot. So how do we do it is we take that order and then we process it in the background. So it's a bulk processing basically. That's the keyword I wanted to accomplish here, but I wanted to paint the picture for you that how we at T-Mobile are doing it in the background. Now, think about there is a microservice which we have, right? Microservice X, which is working fine for any customer who has like 20 lines or so, because it's very easy for us to spin and it takes like a few seconds to have all the 20 lines spinned and provisioned and payment to be processed, billing information to be passed to different domains, receive response back and show success, right? Now, what happened in this case is when we do this and you have now a bulk processor, if we use the same connection pool for that, and create a separate microservice, which is bulk processing. Now that connection pool will have more resources to be provided to microservice Y, which is bulk processing, than microservice X. And if our 20-line customer come, that person will be in pain because connection pool provided all the threads and resources to the bulk processing service. So what we did, we have two separate pools for microservice A, X, and microservice Y, means for a bulk processor and a normal processing services. And that is what we call bulkhead, a pattern where you divide the things. Now, the second pattern is called as CQRS pattern, which stands for Command Query Responsibility Segregation, which means that you are separating reads and writes separately to two different data stores. And whatever you write will be synced or replicated to the read data store through replication. As you can see at the bottom, all the changes are being synced to the read replica. And just FYI, read replica is always NoSQL. That's the very ideal design of a database system to have. Now, I think I talked enough about microservices architecture. I also wanted to share a few things with you that those days are gone when people were living with, North Star architecture. I do not believe in North Star architecture anymore. There is no such thing. Companies are always evolving, markets are always disrupting, new patterns keep evolving. So we at T-Mobile always look for new things, and same every other organization is doing or any other architect is doing. So what happened is, as you can see on the screen here, we talked about Monolith, then we had front end and back end systems with layers, of course. Then we talked about microservices, where you had one API gateway, Monolith front end, of course, and then you had multiple APIs. Now we at T-Mobile are here. We are not only doing microservices, we are doing micro front ends. Means we do have a base application. Think of a container which has a header and a footer and the menus and all that. But in the middle, you will load the micro apps or the micro front ends you will load for the customer journey, whatever it is. So we do have multiple micro apps for payment, for account management, for upgrades, for checkouts. We do have different micro apps which we load in our main container application. And then we have multiple microservices which are catering it. So micro front end is always customer journey specific. For example, a customer is on the website and that person wants to make the payment. So we do not load the payment screen. Rather, we load a very small single deployable unit, a very small micro app which has only payment capability in it. And you can only make payment there. You can do nothing else. So that is where we are going, and that is what the future of architecture look like. And that is where we are, and we keep evolving. Microapp ownership is very important to understand. How do you own it? So if you have multiple micro apps, you will have, of course, styles, forms, validations, and API calls and whatnot. Do not own horizontal, rather own vertical. So always own the app vertically, means one team, just like remember how microservice architecture was. Always own entire stack top to bottom. Do not own horizontal of multiple micro front ends. So having said that, do not own styling of three apps, rather own one single app top to bottom. With all these good, I think, advices and some patterns I tried to share, I will end this with a thank you note. And I hope you enjoyed it and you learned something new about microservices architecture. This article, by the way, is also published on CSharpCorner. You can go and help yourself. There are many other people who are writing on the same thing on CSharpCorner as always. So go utilize the resources, make yourself aware, and thank you so much once again for listening.